Next step of our application is building the schema. First, we need to import libraries. Optional means the value can either be of type string or none. It is commonly used for fields that are mandatory. And again, from Pydantic we are importing base model. It is used to define structured data models with validation, serialization, and deserialization capabilities. The same we are using in models, an item, vector data, and etc. We need item class. Actually fields. That defines Pydantic model, inherits from base model. This model represents structured data with specific field types and validation rules. The fields that we need are ID, optional, name, description, metadata, we describe optional above, and we will add our inner class config. The purpose of the inner class is to configure the behavior of the item schema model. It enables the model to populate its fields from an object's attributes rather than just a dictionary. We actually talked about that in our previous lecture about the models. We are using the same class here, so we are familiar already with that. Our next class is response schema. This class is intended to structure the response for API calls containing fields that describe the operation's result. And we need fields like the success field represents whether the operation was successful. The message field provides additional information or context about the operation's outcome, and the ID that we have everywhere represents the identifier of the resource involved in the operation. So let's summarize. We have item schema for representing an item with optional and required fields, configured to populate fields from attributes, and we have a response schema for API responses, contain fields to describe success, message, and associated resource ID. Our next step is to build the repository, but that actually is going to be a little bit more complicated. First, we need to decide which database we want to use, and there are a couple of choices like Qdrant, that is optimized for ANN, approximate nearest neighbor search, and library like Annoy. That's a little bit funny name, comes from approximate nearest neighbors. Oh yeah! And features like HNSW, hierarchical navigable small world algorithm, filtering, and strong RAG support. Perfect for our case. But there are other vector databases like Pinecone, focused on large-scale vector search and machine learning applications. Weavit, that is open-source vector database with built-in machine learning modules. Milvus, again open-source and scalable vector database for similarity search. Vespa, a real-time big data serving engine with vector search capabilities. Redis, Who doesn't know Redis? Who didn't hear about Redis? It uses additional module actually in this particular case, Redis search vector, and this is in-memory database with vector search support via Redis search module. Elasticsearch, it's also very famous database, not only but database with KNN plugin, general purpose search engine with vector search support. FIASS, Facebook AI Similarity Search, that is library for efficient vector search, but not a full-fledged database. And MongoDB, very famous database again, itself is not a vector database, but with recent updates such as MongoDB Atlas Vector Search, it now offers support for vector-based queries. Another very famous database, PostgreSQL, is not inherently a vector database, but it can be adapted to vector-based operations through extensions like pgvector. Those extensions enable PostgreSQL to store and search vectors efficiently. Basically, you need to learn and understand the algorithms that work efficiently with the vector data, such as HNSW, ANN, and others, before making a decision and choosing a vector database. We will likely cover this topic in the next chapter of these tutorials. For our application, we choose to use Qdrant. You can check Qdrant at qdrant.tech. And to install and run Qdrant, I will use additionally Docker. You can download it from docs.docker.com. Get started if you don't have it yet. You can download it and install it from here. And after everything is complete, it is good practice to confirm that everything's fine by using the command docker v. And yep, everything's fine, everything works. Yay! If everything is fine, we have to pull the Qdrant Docker latest image from the Docker Hub with the command docker pull. Nice. And we have to run the Qdrant container with the following command. But let me explain this command. Docker run is for running. The D stands for running the container in detached mode. Name Qdrant is the name of the container. And P633 blah blah is actually it's mapped the Qdrant port to the host. And yep, it works. Next we have to verify Qdrant is up and running by this command docker ps, and yep, it's up and running. We can also verify in our Docker, and everything works. Yay! And we can come back to the Visual Studio Code. Hey everyone! If you found this video helpful or enjoyable, please give it a thumbs up. It really helps support the channel and lets me know what content you love. Don't forget to hit the subscribe button and turn on the notification bell so you never miss an update on exciting new tutorials and insights. Your support means the world and helps me keep creating awesome content just for you. Thank you!